All right, good afternoon, guys. We got 5, 6 today, proving that quadrilateral is a parallelogram. All right, as you can see here, we're a parallelogram with some diagonals. What do we know about parallelograms? What can we prove already? What do we know? Mike? Parallel sides are congruent. Not necessarily. That's wrong. Opposite sides are parallel and congruent. So opposite sides are parallel and congruent. Okay? Next. Yes, opposite angles are congruent. So angle D will be congruent to angle B. Angle A will be congruent to angle C. Very good. What else do we know? What do we know about the diagonals? No? Yes. Okay. The diagonals of a parallelogram are not congruent, but they do bisect each other. So these guys will be congruent, and these guys would be congruent because, again, the diagonals bisect each other. So today, knowing that, this lesson should be really easy. We're going to figure out ways to prove that a quadrilateral is actually a parallelogram. All right, so let's check it out. Number 1. If both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. And it's reverse of the definition of a parallelogram, of course. Okay, number 2. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Okay, number 3. If one pair of opposite sides of a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. If the diagonal of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. And this is the converse of the diagonal property. Remember, the converse switches if P then Q, changes to if Q then P. And last but not least, if both pairs of opposite angles are congruent, then the quadrilateral is a parallelogram. Okay, let's see how this works. We've got given ACDF is a parallelogram. Angle AFB is congruent to ECD, and they want you to prove that quadrilateral FBCE is a parallelogram. So we're trying to prove that FBCE is a parallelogram. So the first thing, of course, as always, is our given. ACDF is a parallelogram. And of course, that's going to be, because it's given. What do we do from there? What do we know from there? Okay, let's go with that first one. Good job. AF is congruent to DC. We know this. AF is congruent to DC. Why? Definition of parallelogram. Very good. Okay, what would the next one be? Angle A is congruent to angle D. Very good. Angle A is congruent to angle D. And yes, sir. Again, definition of parallelogram. Very good. Now, let's use our given again. Let's go ahead and say that angle AFB is congruent to angle ECD. So I have here angle AFB is congruent to ECD. Everyone with me so far? And of course, that's given. Yes, sir. No. No. This is given. AFB is congruent to ECD because it's given. Thank you, son. Okay. Yes, sir. Come again? Yes, sir. What are the triangles? Very good, son. Very good. We got triangle AFB is congruent to triangle DCE. Why? Angle, side angle. Good job. So now I know that these two guys are congruent. So what can I tell now? Mike? Very good, son. FB is congruent to EC, right? And that's, of course, because of CPCTC. And then? Very good. Nice. Let's put that out there. AB is congruent to ED, also because of CPCTC. We had a little snafu there. All right, no big deal. So AB is congruent to ED. All right. Now what? No, you already have a hint here. Definition of parallelogram, it'd be AC is congruent to FD. Okay. We could have used the addition property, but you would have had to first prove that FE was congruent to BC, so that's going to be difficult. But knowing that this is a parallelogram, you know that AC has to be congruent to DF. But now what can I prove? Say it again? Yes, sir. BC is congruent to FE because of subtraction property. Very good. Yes, sir. Because AC to FD, you're not subtracting anything, son. That's definition of parallelogram. Thank you for asking. Because without knowing that AC is congruent to FD, you cannot prove that FE is congruent to BC. We need to subtract ED from FD and AB from AC to get FE congruent to BC. Remember, when you subtract congruent parts from congruent segments, the differences are going to be congruent because of subtraction property. Great question. Thank you. And now, what do we have? Mike? Okay, yeah, we get to our proof. FBCE is a parallelogram. Why? Fantastic, son. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. No, you cannot write definition of parallelogram for these. You have to prove why. Sorry. So in the end here, that has to be stated. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Does that make sense, gentlemen? All right. May we continue? Could there be more than 4 sides in a parallelogram? No, because a parallelogram is a quadrilateral, and a quadrilateral, by definition, is 4 sides. Thank you. All right, next. All right, let's see what we got here. Okay, I didn't go so fancy on this one. I'm going to write these in, but let's see if you guys can tell me what to write. Okay? What's the first thing we would say here? Of course. Okay. Triangle car is isosceles with base CR. And that's, of course, given. Now, what do we know from that? What will we know? Very good. AC is congruent to AR. So AC is congruent to AR. Why? Definition of isosceles. Okay. I wouldn't go there yet. Didn't we just state that AC was congruent to AR? Isn't there a given involving AC as well? So I would say AC is congruent to BK. Given. Very good, son. Then you could say AR is congruent to BK because of transitive property. So basically what happened here? We know that AC was congruent to AR, no problem. AC was congruent to BK, given. And now we know that AR is congruent to BK. Does that make sense so far? Okay, now what? Now let's go for the angles. What do we know? Okay, there's a couple angle R's. Which one? Correct. Angle C is congruent to angle ARC. So angle C is congruent to ARC. What else do you know about angle C? Look at the given. Look at the given. Angle C is congruent to angle K. So yeah, hold on. This is definition of isosceles. And this guy here is given. So now that I know that angle C is congruent to ARC and angle C is congruent to angle K, what can I say? Angle K is congruent to angle ARC, transitive property. Okay? Now what? That's going to take you too long. Think about what we have here, guys. Don't we have an F? There you go, corresponding. So you can say that AR is parallel to BK. How do I know that? Well, if corresponding angles are congruent, then you have parallel lines. And now that those are parallel, what can I prove? Quadrilateral BARK is a parallelogram. Very good, son. If one pair of opposite sides is congruent and parallel, comma, then the quad is a parallelogram. Does that make sense? See, it's very powerful stuff. Does that make sense? May I continue? Not yet? We've used substitution before in proofs all the time. Transitive is if A equals B and B equals C, then A equals C. Substitution is A equals 30 degrees. So like I was saying, if A equals 30, and I say angle A plus 60 equals blank, you could use substitution to replace angle A with 30 degrees. No. Sometimes, I mean, I can say, yes, Nick. No, that'd be transitive. Substitution, look at your old proofs. Okay? Thank you. All right. Now, what if I have this quadrilateral here? Okay? I'm going to show you the angles, what they are right now. And we want to show that QUAD is a parallelogram. Okay, so if I have 3x times x squared minus 5x, and I've got x squared to the 5th power, and I've got x to the 10th power, and I've got 3x cubed minus 15x squared. How can we show that quadrilateral QUAD is a parallelogram? Yes, sir. How? No, that's not right. You haven't proven that Q is equal to A yet. There, no, 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 no. Think about this easier, guys. Mike? Thank you. Let's use a distributive property here. If you multiply 3x to x squared and negative 5x, isn't that going to equal 3x cubed minus 15x squared? That's the same thing as angle A, correct? How do I simplify angle U? X squared raised to the 5th power is x to the 10th. Does that not equal angle D? So if opposite angles are congruent, then the quadrilateral is a parallelogram. So since Q is congruent to A, which are opposite angles, and U is congruent to D, which are opposite angles, this quadrilateral is a parallelogram. Does that make sense? Okay. May I? Last but not least. All right, boys. Let's figure this one out. This one's easy. Okay. We're going to first start off with, of course, NRTW is a parallelogram, and that's given. What do we know about that? And let's look at what we're trying to prove that may help you out. They want to prove that XPSV is a parallelogram. Now let's think about those angles that would be associated to those sides. That is true, but it's not going to help you. What's going to help you here is angle N is congruent to angle T. Definition of parallelogram. Okay, so I got angle N is congruent to angle T. Okay, now what? Don't we know that NX is congruent to TS? So NX is congruent to TS given. Come again? No, that isn't going to really help us. We could state the given again now. WV is congruent to PR. Just give me a couple seconds, guys. Relax. WV is congruent to PR. That's given. Don't we also know that, so let's go ahead and mark that. WV is congruent to PR. But don't we also know that NP is congruent to WT? So NP is congruent to WT. Why? Definition of parallelogram. NR. I apologize. Thank you. That's NR is congruent to WT. Now what will you say? NP is congruent to VT. Why? Congruent to VT because of subtraction property. Okay. Now what? What is it? No. Think about the triangles. It's going to be NXP is congruent to TVS. Why? Side angle side. Does that make sense? And then from there, XP would be congruent to VS. And then from there, because of CBCTC, of course. And then from there, what do we say there? Wouldn't we be able to prove the exact same thing with WXV and RPS? So, okay, I know you said that, but either way, we would have had to done both. So you can say triangle WXV will be congruent to RSP, and you could say the following. Proven in the same manner as triangle XNP and STV. So it's a little bit of a shortcut. Then from there, XV would be congruent to PS. And no, that wouldn't be given. That'd be CPCTC. Then you can say that XPSV is a parallelogram. If opposite sides are congruent, then the quadrilateral is a parallelogram. Have a wonderful day, guys. God bless you. Bye-bye.